All right, functions. Now, you should always think of functions just as a set of rules. And sometimes we call functions formulas. All right. Now, summation notation we just use is an example of a function as well. All right. Now, there are very two important variables, or we can think of as components in every function. Right? It's called the argument and the parameter. All right. Now, so here is a function where what you likely seen in algebra 2. All right, here's a square root of x plus 20 divided by x. Okay, and so now what you want to focus on or recognize is which is the argument and which is the parameter. Right. Now, the argument is always inside the parenthesis. Okay, and so the argument in this case will be the variable x. X is what goes in the function, right? And the parameter is basically anything that defines the function. So in this case, 20 here is a parameter. Now, the way we read this, f of x is read as function of x. Now, that's not because the letter f, right? Because I can have g of x, and this will also read as a function of x. Right? And another name for this will be function g. Right? So the letter just gives the name of the function, but we read as this is a function of x. So, like for example, right, if I have g of y, this will be a function of y, meaning y is the argument. So y is the variable that we will put in. Okay. So let's go back to our function over here. And what do I mean by a parameter? Well, for example, I could write this function like so. Right, so here is the square root of x plus a over x. So now this function is not quite defined yet, right? Because I need to know what a is before I can evaluate this. Okay, so this is what we will call a family of function. Okay, what that means is depending on what a is, then the function will change. Right? Okay, and now let's let a equals 20. All right, so if we let a equals 20, now we have set the parameter. Okay, then now in this case, f of x, I can just rewrite it as square root of x plus 20 over x. Okay, now how do I evaluate it? Okay, well, I put in, so I have an argument. So let's say let x equals 2, and it's just very simple substitution. Okay, I'm gonna take wherever I see x, I'm gonna plug in 2. So here I have a square root of 2 plus 20 over 2. Okay, or square root of 2 plus 10. Okay, and generally you can leave it like that. If you want more specific or approximation, you can take the square root in your calculator. Okay. And it doesn't have to be a number. The argument doesn't have to be a number, right? If I have f of b, for example, probably shouldn't use b, might be like a 6, but that is a b. Okay, and then same rule applies. I just, wherever I see x, I simply replace it with b. 20 over b. Okay, now what is that? Well, I don't know until I know what b is. Okay, but now this doesn't change. What I mean is b is still the argument. B is not the parameter. Right? So the argument is whatever is inside this parenthesis here, and that's the value we plug in to evaluate. Okay, now one of the function that we will be using quite often later on in this class, right? In this class is a probability. It's a probability function or a specific probability function. But here's what that function will look like. So I have f of x equals e to the negative lambda, right, times lambda to the x over x factorial. Okay, now this looks like a lot of Greek. It is quite literally a lot of Greek letters here, but don't worry. Okay, this basically is one of the hardest probability function that we will have to calculate. Okay, now first let's see what is the argument and what is the parameter. So the argument is easy. Argument is just x. Okay, so x is the argument. Okay, then what is the parameter? Well, parameter is anything that is not set, right? That can still change, okay? Now, so I have two options here. I have the E and the lambda, okay? So E is not the parameter, and because E is already set, E is just a number, right? It's kind of like pi. Right? Pi is 3.14, blah, 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 and E is just 2.37, something like that, right? You can find it in your calculator. So E is just a number, right? So that's not the parameter. So here, the parameter is lambda. Lambda is the parameter. Okay, now what does that mean? That means that before I evaluate this, I need to know what lambda is. I need to find out what lambda is before this is the function. This is a function that I can evaluate. Okay, so without lambda, I can't evaluate the function. Now, okay, so suppose, and again, don't worry about what this means yet. Right, when we get to that chapter, you'll see this again, and then we can talk about what this actually represents. But right now, let's just treat it as just some random function we found. Okay? Now, suppose that lambda equals 4. Okay, so now I have my parameter, and I have a full function that I can evaluate. So I'm just gonna rewrite it. Over x factorial. Okay, and now I can evaluate. Now I can evaluate this function. Okay. Now, by the way, some of you might have forgotten this explanation point. What does this mean in math? Okay, so this means factorial. So this is factorial. Okay, what is factorial? So factorial, by definition, is a simple mathematical process. So, for example, if I have n factorial, this simply equals n times n minus 1 times n minus 2 times all the way to 2 times 1, and that's it. Okay, so for example, if I have 4 factorial, then this equals 4 times 3 times 2 times 1. Okay, and that's all factorial. That's all factorial is. Another shorthand, essentially, compact way to write a long process. Okay, all right. Now, so let's say, okay, so I have lambda equals 4, and so now that I have my whole function, let's find f of 2. Okay, let's give this a try. So I have f of 2 equals, and then simply plug it in. Don't overthink it, just copy it down. Okay, and then wherever you see x, just replace it with a 2. Okay, so 4 squared is 16. 2 factorial, just 2 times 1, will just be 2. So this just equals e to the negative 4 times 8. And if you put in your calculator, okay. Oh, by the way, if you remember from algebra, with a negative exponent, that means I can bring this whole thing down to the denominator. So I can rewrite this as 8 divided by e to the 4th power, like that. So these two are equivalent. Put that in on the calculator, and this is what you should get. Interval. Now, whenever we solve a math problem, when we say solution, or when we hear the phrase solution set, it simply means that all of the x value that will make the statement true. Right? So for example, if we have an equation, okay, let's say we have a very simple equation here, 2x equals 4. Okay, now I want to find the solution of this equation. Okay, and everybody knows, divided by 2 on both sides, we get x equals 2. Okay, so x equals 2 is the solution. It's the only solution. Okay, another way we can phrase it is we can say, or x equals, put bracket, 2. Okay, this is a finite set, right, with one element. Okay, it's a finite set because there's only one. Well, there's a finite, right? It's not infinity, with one element. Okay, and so that's what we mean by a solution set. Okay? Now, whenever we solve inequalities, however, right, the solution is typically a continuous set. Okay, what do I mean by that? So if I have 2x is less than 4, for example, right? Now, so you guys remember this, if I divide it by 2 on both sides, I'm going to get x is less than 2. Okay? Now, How many solutions are there? There's infinite, because there's infinite number of numbers that are less than 2. Okay, graphically, if I look at it on the graph, I have 0 here, 2 here, 1, right? Then, typically think back in your algebra class, we usually write it like that, right? Open circle, right? So everything below 2 is the solution. Okay. Now we're not going to be solving really any inequality inequality problems in this class. However, we just want to get used to writing things, writing sets, writing continuous sets. Right? So the way we can describe this notation. So graphically, right, we can see it like this. But how do I, if I don't want to graph it, how do I express the same thing in terms of a set? Okay, so we can say this. We can say x equals, and now here, right, we're going to use parentheses. So whenever we use parentheses to describe a continuous set, right, we always start from the left and we go towards the right. Now from the left here all the way to the end, that's going to be negative infinity. So we just say negative infinity, comma, and then go all the way to 2, parenthesis. And that's it. And this is an infinite set. Okay? So intervals, right, are going to be ways we can use to describe continuous set. Right? Like for example, if I have, let me do another inequality here. Let's say that I have this inequality, negative 2 less than 2x less than 4. Okay? I can solve this divided by 2 on all three sides, or 3 for all 3 parts, and then I get negative 1 less than x, and then less than 2. Okay, that tells me that x is between negative 1 and 2. Okay, and this is the perfectly acceptable answer, or it describes a set. But if I want to write it in the set notation, right, I will do it like this. All right, I want to express that x, my solution, is between negative 1 and 2. I will just put it in the parenthesis, negative 1, comma 2. Like so. Okay? All right. Now, if you remember from the algebra class, like there's, we have distinction between equal, so hard bracket, open bracket, closed bracket, and such. We're not going to make that distinction here, so don't worry about that. Okay, all right. So just you can always express intervals like so. So here is an interval between negative 1 and 2. Now, in statistics, we often calculate interval by starting at the center. Okay, what do I mean by that? So we what we care about is we have a center estimate, and then we have a left bound or lower bound and an upper bound. So we typically write it like this: we have a center plus or minus, right, plus or minus d. Okay. Now, what does that mean? That means so that I can write that as an interval like this: c minus d, comma c plus d. Okay. Let me give you an example. Right. If I have 5 plus or minus 7. Okay. This is just a shorthand. It's just a shorthand way of writing an interval. Okay. So I can translate that to express it in the actual interval. It will be 5 minus 7, comma 5 plus 7. Okay, let me simplify that, or just complete that calculation. It would be negative 2, comma 12. Right, that's my interval. So I can go from here. This is another just another way of writing the same thing. Now, how is this helpful? Well, this tells me my center. So this is an interval centered at 5. Okay, and this, right, is my width, or more specifically, half the width, right? Because if you notice, what's the total width of this interval? Well, it's 7 plus 7. So this is one half the width. Right? So this is going to come in handy, right? Because when we get to later chapters, right, these width and these centers will have actual meanings or interpretations. Okay, so it's good to identify, what these two are, and then now once we write it out like this, when we have an interval, right, this part, the smallest number, we call this the lower bound. Okay, and the larger number, we simply call that naturally upper bound. Okay, so let's do a little example here. How we use this use these interval notation, or I should say, use these formulas to write an interval. So here's the form that you will likely see. Okay, again, it looks complicated because you don't have numbers. You have just a bunch of letters, English letters and Greek letters. But don't worry, right? It's just a simple substitution, right? These are simply identities or formulas, whatever you want to call them, however you want to call them, and and these can be solved very easily simply by just plugging it in. Okay, just substituting things in carefully. Okay, so here's a process that we are going to be doing pretty often. You're given this you're given this interval notation, and then you're given the values of each of the variables. So let's find the interval. Okay, now then the first step you do is just simply plug in everything. Okay, so I'm going to rewrite this. X bar is 25, plus or minus. My z is 1.64. Now, whenever you have something like this, I recommend using parentheses. Okay, and that way your variables or your numbers don't pollute each other, right? They don't collide with each other. Sigma is 12, n is 25. So we have square root of 25 here. Okay, all right. So when you do this calculation, what I recommend is do this part first, okay? Because that will be significant, right? This will have a meaning, which we'll talk about later, later chapters, okay? But so you're gonna need to find this anyway. So go ahead and just put this part in the calculator first. So if you do that, then this is what you'll get. Okay. All right. Now, once you get that, then we can write it in as interval. So the lower bound, it will be 25 minus this number. Upper bound, 25 plus the same number. Okay. And then simplify that. They'll get 21. So that's our lower bound, and we're going to use LB as a notation, and that's our upper bound. That's the upper bound right there. So go ahead and give this bottom one a try. Right? And again, don't worry too much. I have a couple different letters here, but it doesn't matter, right? Because the only thing that matters to you is what is the value of these. What is the value of these numbers? So go ahead and give it a try. Pause the video and then check it and then play it again once you have it. Okay, here we go. Okay, use the parentheses. It's going to help you a lot keeping things clear. Okay, calculate this portion first. Okay, and then now we can write down the interval. Okay, I'm going to go a little quicker. Okay, and that's our lower bound and upper bound. Now, in statistics, right, we will be converting values to a z-score. And don't worry, we'll learn what that is soon enough, okay? So later chapters, okay? But before we do that, right, a good analogy of this is conversion between Fahrenheit and Celsius. Right? So, for example, right, if you're traveling, to Europe, right, or basically anywhere else in the world, really, and then you have a cookbook, right, but everything is in Fahrenheit, right, and then you want to measure, but you want to measure, when you're cooking, but then the only thermometer that they have is Celsius. So you will need to convert your Fahrenheit into what Celsius is, or vice versa, right? You want to convert that Celsius, or you want to measure everything you measure is in Celsius, and then you want to know what is that in Fahrenheit. Okay, and now so we have a linear relationship between the two variables. Let me write that down. That's really important. So there is a linear relationship between Fahrenheit and Celsius. Right? Now, if you have a linear relationship between any two variable, right, then that means mathematically you can always express them like so, right? Y equals mx plus b. Okay, so remember this is your point slope intercept form, right, from algebra, right? And this is your basic linear equation or linear function. Okay, now for now we can we can derive this, but I'll just give it to you here, right? To convert Fahrenheit to Celsius or vice versa, right? We have this relationship: Fahrenheit equals 1.8 C plus 32. Okay, and you can derive this knowing 2 points, okay, and so on. We don't have to worry about that. So for example, right, if I take a thermometer and I measure that Celsius, okay, equals 56 degrees. Okay, what is that in Fahrenheit? Well, I'll just simply plug it in. Right, F equals 1.8 times 56. Again, here notice the use of parentheses. Right? I want to make sure I separate. I don't want to confuse 1.8 and 56. So I use the parentheses there. Okay? Plus 32. Okay? And just plug that in the calculator. Okay, so this equals 132.8 degrees. Okay? All right. And so it's just a conversion, and there's a linear relationship between Fahrenheit and Celsius. Now, when so later on, right, one of the common thing we'll do in this class in statistics is to convert things to z-score. Okay, and you want to think of the analogy works because imagine that we only understand everything in terms of z, but we measure everything in terms of x. Right? And so you have x values, and then you need to convert them to a z value. It's very simple. Here's the formula. Don't worry about what the formula means. All you need is this mu. This is the Greek letter for mu. Okay, and this is the Greek letter for sigma. Okay, we call it sigma and mu. Okay, right? Okay, but anyway, just recognize, pattern recognition. You say mu, okay, I just plug that in. So here, I can simply write that as z equals x minus 23 divided by 13. Okay, so here I have an x, and I simply want to convert that, into a z-score. Okay, so I just go, well, z equals 20 minus 23 over 13. Okay, plug in calculator, and we always want to express this in terms of decimals. 3 decimal places is fine. That's pretty standard. Okay, negative 0.231. Okay, we'll do one more. Z equals 31 minus 23 over 13. Okay, then put that in the calculator, right? And then you should get this. 615. Okay. All right. Now, what about if x is equal to mu? Right. Now, let's write that down. X is 23. Mu is also 23. Okay. Then in this case, you have a 23 minus 23. So as long as x is equal to mu, it doesn't matter what sigma is. Doesn't matter what is in the denominator because that is simply going to be 0. Okay. All right, so that's simple stuff. Now, sometimes, right, we are given the z value instead and need to solve for x, right? So just like sometimes where we have the Fahrenheit, but we need to convert it to Celsius. So what do? All right, we don't need a new formula, okay? All we need is just remember our algebra tricks, okay? So I have z equals 1. So let's say I have 1 equals. I don't know what x is, okay? But then I know what everything else is, right? Mu is still 23. Okay, sigma is still 13. Okay, all right. Okay, and so here, right, we multiply. So just remember your algebra. Multiply both sides by 13. Okay, that gets canceled out. So I get 13 equals x minus 23 plus 23 plus 23. Then that gives me x equals 36. Okay. Okay, all right. Give the next two a try. Right? Give the next two a try. Okay, you can feel free to pause the video and start the video again once you got the answer. Okay, there we go. So z equals negative 2.1. Right, this will be x equal negative 4.3. Okay, I'll skip the steps. And z equals 0, right? Now, I don't need to solve here, right? The only time, right, when z equals 0 is when x equals to mu. So then this x equals 23. Okay, we can see that above there. Okay, all right, we'll do this last part here. Same concept, right? It's just that often, sometimes we will need to do a fraction within a fraction. Okay, this is only confusing, or at least people usually only make mistakes due to a calculator input error. Okay, and so now this you just have to kind of practice. And if you by the way, if you are struggling or you don't remember how to put in how would you put this inside the calculator, please let me know. I can help you, and then I can help you individually. Okay, but process is the same. I have a couple more parameters here now, so I'm just going to substitute that in and write it out again. X minus 23 over 13 over root 8. Okay, all right, and then now the process is very simple. Plug in x, right? Plug in x, and then finish everything in the calculator. So for example, number 1, I have z equals 20 minus 23 over 13 over root 8. And so you could do this, let's say, depending on what calculator you have, you could do this in 2 steps. Figure out what the numerator is and then the denominator. However, the only problem with that, if you do that is, just make sure you don't round too much. Right? Because this is an irrational. Root 8 is an irrational number. You're going to have a lot of decimal places here, obviously. And so you don't want to round too much. Otherwise, you're going to get a different answer than what I have. Okay, or what's in the book. All right. So try your best to put this in 1 step in the calculator. And if you do that, then you will get this. Okay. All right, so I'll let you try the other 2. I'm going to go ahead and give you the answer here, but go ahead and put it in the calculator if you can. But this one will be z or equal. And the last one, z will equal 0. Right? It doesn't matter what the bottom is. If the x is equal to 23 and the mu is equal to 23, if they're equal, then the z score must be 0.